Today we're going to discuss the intermediate value theorem. And what that theorem says is f of x is a continuous function on the closed interval ab, and L is some number between f of a and f of b, then there exists at least one c between a and b such that f of c equals to L. So let's see, what does this mean? What are we talking about? Well, a continuous function. So continuous means there's no breaks in the function, and all polynomials are continuous everywhere. So continuous, f of x is continuous, no breaks. In between a and b, no breaks. And L is some number between f of a and f of b. Well, here's f of a. See, a gives me this y value of f of a, and b gives me this y value of f of b. So there exists some L. L is some number between f of a and f of b. So let's put L on our graph. So let's say L is here, in red. So L is between f of a and f of b. Then there exists at least one c between a and b such that f of c equals to L. Well, between a and b, we're saying there's one c, at least one, such that f of c equals to L. If I come back with my L, wherever it hits the function, and we see it hits the function there and we drop down, what we're saying is that there is a c in between a and b such that when I put this in the function, I get L out. So that's the intermediate value theorem. Now how does that apply to polynomials? Well, it always applies to polynomials for any two values of a and b because polynomials are continuous everywhere. But more specifically, we can use this to find what we call the zeros of a polynomial. Because if f of a and f of b are opposite signs, then we know there's a zero in between there. So let's redraw our graph to see that, specifically for zero. So what we're saying here now, with the intermediate value theorem for polynomials, if f of x is a polynomial function, so we know it's continuous everywhere, and if f of a and f of b have opposite signs, then there exists at least one c between a and b such that f of c equals 0. Let's see that again. So we're saying a polynomial, we have a and b, f of a is now negative, it's below the x-axis, f of b is positive, above the x-axis. So f of a and f of b have opposite signs, and it doesn't matter which order. But as long as they have opposite signs, we know, because the intermediate value theorem says this, for any value in between f of a and f of b, there's a c to give that value. Well, specifically for 0, which has to be between negative and positive, or positive and negative, so for 0, there is a value between a and b that gives me that 0. And what is that value? Well, for this function we don't know because we don't have an equation, but we can see it. That value here is here where it crosses the x-axis. That's the 0. So this c, whatever that value number that c is, gives me 0. And there's at least one. In this case, it's just one. But it says there's at least one. So there could be many more, depending on your graph. So let's see how we can apply this intermediate value theorem for polynomials to find the 0 specifically. Alright, so we have this problem. Show that f of x equals x cubed minus 2x minus 5 has a real 0 between x equals 2 and x equals 3. So according to the intermediate value theorem, we know this is, first of all, we know these are continuous. This is a polynomial. It must be continuous. And so according to the intermediate value theorem, we have to just figure out f of 2. So f of 2, plug in 2 and do my function. F of 2 is 2 cubed, 8 minus 2 times 2. So 8 minus 4 is 4 minus 5 is negative 1. And then find f of 3. F of 3 equals, we'll plug it into the function, 27 minus 6. 27 minus 6 is 21, minus 5 is 16. And since these have opposite sides, since f of 2 and f of 3 have opposite signs, it means that the function is crossing 0. To go from negative 1 to 16, you have to go through 0. And so there's some number between 2 and 3 that gives us that 0. So to find that c, that value between 2 and 3, that gives you 0, there's some algebra involved. However, you can also graph the function to see what that exact value between 2 and 3 would be. So let's take a look at the graph of this function. So here's a sketch of the graph of this function x cubed minus 2x minus 5, and we see f of 2 was negative 1, that's this point here, and f of 3 was 16. So you had to cross the x-axis to go from negative 1 to 16, and it crosses right here, that's the 0, and if you plug that into your calculator, you'd see that value is approximately 2.0946. So that's my 0. In other words, f of 2.0946 gives me 0. That's my C. And we know that because of the intermediate value theorem. We know that's the 0. So imagine, how do you find zeros like this? And of course we did the calculator, but the calculator must be using some kind of program. And there are several methods to actually find zero based on the intermediate value theorem, where they keep bisecting these intervals and getting smaller and smaller and closer to that value that gives you 0. So that's one method. But that's all because of the intermediate value theorem.